let's get going with our actual lesson. And I did put this up on Tuesday and said, off you go, figure out what this is and do the congruency for it. So we're just going to have a quick run through it. I'll give you 30 seconds just to look at the question again. If you didn't get around to it, not a train smash. It was just there for those who wanted something to do because they don't have anything else to do. No, because you want to practice your congruency. That's why. Okay, so we have in the diagram AB parallel to DE and DC equal to CB. So we have to prove that AC is equal to CE and AB is equal to DE. So now, if you are asked to prove that lines and things are equal, congruency is your best friend. Because if you can prove two shapes are congruent or two triangles are congruent, it means that they are exactly the same in every way. So we're going to start, and if you don't know where to start, always start with what is given. What is given? Okay, so two sides that are equal, that's given. Perfect. Can we use that for congruency proof? Maybe we can. The next thing that's given are these parallel lines. So parallel lines are also your friend because they give you angles that are equal. So if we do alternate angles here, we can say that this angle ABC is equal to this angle here, EDB. All right, and so we've got a side that's the same. We've got one angle. And what if we go C1 equal to C2 because they are vertically opposite? Then we can do a nice congruency proof here of triangle ABC congruent to triangle ADC. So I've given you lots of clues now. I'm going to leave you for 2 minutes to write out your congruency proof. And just make sure you understand that we are proving the congruency, because if the triangles are congruent, then they are exactly the same in every way, and then AC will be equal to CE. So it's almost like a backwards process that you go through. But yeah, so I'm going to be quiet 2 minutes, write out your congruency proof, and then we'll check back in about 2 minutes. Okay, so let's have a look. Always start off by saying which two triangles you are going to prove congruent. So in triangle ABC and triangle EDC, the first statement we are going to make is the stuff that's given that's equal, which is DC equal to CB, and that is given. Then we can say that ABD or ABC is equal to angle CDE. And the reason for that is they are alternate angles and AB is parallel to DE. Don't confuse the two. I think some people were thinking that AB is equal to DE. AB is not equal to DE. They are parallel, and that gives you the alternate angles. Okay, so far we've got a side and an angle, and then lastly we're going to do angle C1 is equal to angle C2. And the reason there is because they are vertically opposite. And that gives me another angle. So my reason for congruency is going to be angle, angle, side. So therefore, triangle ABC is congruent to triangle EDC, angle, angle, side. Which then means the two triangles are exactly the same in every way. So that means that AC must be equal to CE. So this side must be equal to this one because of the congruency. So AC equal to CE. And the reason you're going to give there is that triangle ABC is congruent to triangle EDC. No other reason is a valid one. Okay, that is your only reason for congruency, for those two sides being angle equal. I'm getting my words mixed up. No wonder I posted that woozy face, because I'm getting all my words mixed up. Okay, and then let's see, why is AB equal to DE? AB equal to DE for exactly the same reason. AB is equal to DE because of the congruency. The two triangles are now congruent, so they must be the same in every way. So that side is equal to that one. Just do a little bit better here with highlighting the side. There we go. And we're going to copy that reason exactly. Congruent to triangle EDC. Okay. Pop in the chat a thumbs up if you are happy with that. Thumbs up if you understood, and if you are happy with our question and everything we did just now, proving the congruency, and because of the congruency, the sides are equal. Tiamu, why did I do it this way last year? Labeling side is on the right. Why didn't I do that? Because I didn't tell you. Now I am telling you. That's why you are going to do it that way now. And if you label on the side and it's not one of your congruency cases, one of the 4, then you know you're going wrong. So this is Ms. Barnard's foolproof way of proving congruency. Can't go wrong. Okay, right, guys. So wonderful. Why do we write SAA or AAS? It's the same, Sandesile. Angle, angle, side, or side, angle, angle. Doesn't matter. It's the same. Yes, Lesego, the only reason those sides are equal is because of the congruency and because the two triangles are exactly the same. Okay, on we're going to go and look at our properties of quadrilaterals. Again, a little bit of revision of your grade 9 work. But I just need to switch screens because we're going to get fancy here with a PowerPoint. So I'm going to share different. Here we go. Ms. Coco, is that showing a display, a PowerPoint?
Very nice, ma'am. Very nice, yeah.
A bright purple PowerPoint. Okay. Right. Well, I hope this is as intriguing as I've built it up to be. Okay, guys. So, first of all, let's just talk a little bit about what a quadrilateral is. So, pop in the chat. Quadrilateral, what is it? How would you define it? How would you describe it to somebody? Four-sided shape, nice. Four sides, yes. What else? Quadrilaterals, four sides.
I tried making sides water.
Four sides and four angles, nice, okay. So it's a two-dimensional shape with four sides. And what about the angles? Nice, Emmanuel. Yes, the angles add up to 360. And of course, all the sides are straight. Okay. So that's like the full-on reason or the full-on description of a quadrilateral or a definition. Angles add up to 360. All the sides are straight. And now we're going to look at which quadrilaterals we're actually dealing with, because we can have irregular ones where all the sides are different, and then we can have the ones that we are familiar with, like the first one we're going to do is a square. So what are some of the properties of a square? Pop it in the chat. Square you've learned since like grade 1. All the sides are equal. Give me something else as well. The angles, yeah. The opposite sides are parallel. Yeah, opposite sides are parallel. And all the angles are equal. And each of the angles are 90 degrees. Okay. Emmanuel saying about the diagonals. Right, good stuff. Okay, we can move on to the next one, which is related to the square, the rectangle. So what are some of the properties of a rectangle? The opposite sides are equal. Nice. Okay. Don't forget about the parallel part as well, eh? The opposite sides are parallel. Opposite sides equal. Opposite sides are parallel. All the corners are 90 degrees. So important. Can squares be classified as rectangles? And can rectangles be classified as squares? Have you ever thought about this? So I would say that a square is a rectangle, but a rectangle is not a square. Yeah, okay, because a square has all the sides equal and the 90 degrees, the 90-degree corners. Okay, next one. This is actually my favorite shape, is a rhombus. What are the properties of a rhombus? All the sides are equal. What about the angles? The diagonals bisect at 90. Well done, yes. Sides are parallel. The angles, the opposite angles are equal. Two of them are acute and two of them are obtuse. Chinomerum, what bisects at 90 degrees? The diagonals bisects at 90 degrees. Yeah. Now, what other names could be given to a rhombus? Is it a square? Is it a parallelogram as well? Is it a rectangle? I would agree that a square, like a rhombus, is also a parallelogram because the opposite sides are parallel. Both pairs of opposite sides are parallel, so a rhombus is also a parallelogram. So a square is also a rectangle is also a parallelogram, and a rhombus is also a parallelogram. Okay, so this is actually the one that we're going to work with a lot, which is the parallelogram. So what are the properties of a parallelogram? The diagonals bisect. Well done. A square is also a parallelogram, yes, because the opposite sides are parallel. The opposite angles are equal. Nice, you guys know your properties very well. Two pairs of equal parallel sides. Opposite angles are equal. Two angles are acute and two are obtuse. And a rhombus is a parallelogram. And why do we say that? Because of the sides that are equal and parallel. Right, last one, I think, is the trapezium. Yes, Junior, that's right. The diagonals of a parallelogram bisect. Okay, so a trapezium, what are the properties of a trapezium? We only normally have this one. Yes, it's a 2D shape and only one pair of opposite sides are parallel. That's right. Okay, here's my least favorite shape. I don't know why I don't like a kite, but I don't know. There's something about it that's just not, I don't know, makes me uncomfortable looking at a kite. There must be like a phobia of kites. I wonder what it's called. I think it's because the other ones make so much sense. Everything's parallel, everything's equal. It just fits. And then there's the kite. It's just like, where did the kite come from? Okay, so two pairs of equal adjacent sides. Yes, Buchle. Do you
Ma'am,
also not like kites?
what exactly is the difference between a rhombus and a kite?
A rhombus has all the sides equal, and a kite has two pairs of adjacent sides equal. So do you see here that only these sides, that's what it means with adjacent. But with a rhombus, all the sides are equal. I think a rhombus can also be classified as a kite. Miss Coca, I think we need to check that fact because of the adjacent sides that are equal. But I need to check that. Okay, let's see. Back to the kite. Two pairs of equal adjacent sides. The diagonals bisect each other at right angles. And then one pair of opposite angles are equal. And that's it. What else did you guys say? The longer the perpendicularity is there. Yes. Yes, Zimamkele, nice. The diagonals bisect the vertex angles, or the corner, what's the word? Oh, see, that's why I don't like the kite, because it just leaves me. But I know what you mean, Zimamkele, you're right. And the longer diagonals form two isosceles triangles. Yeah, and the same with the shorter ones. That's right. Okay, we're going to do a quick little quiz here. So the description is going to come up and you can pop into the chat which shape is it. Okay, I think this is quite easy, so we're going to go quick. All of my sides and angles are equal. What am I? Making up names is my thing. Square. Yes, that's a square. I'm a square. Okay. All of my sides are equal and I have two acute angles. What am I? Nice. Rhombus. Well done. Okay, I have one pair of parallel lines. What am I? Yes, Masood, it's trapezium. Good. My adjacent sides are of equal length and I have one pair of equal angles. What am I? Chinamiram says, everyone says kite. Well done. I have four right angles, but my sides are not all equal. What am I? This one's easy too. Rectangle. Rectangle. Good stuff. Okay, let's see if we can do some quick angles here. What would you say B is and what is C? What is B equal to and what is C equal to? And the shape is a parallelogram. B is 70. I agree. Opposite angles are equal, so C is also going to be 110. That's right. Okay, we've got trapezium. It's a regular trapezium. So to a regular or isosceles trapezium. So what will D be and what will C be? Be careful, guys. The trapezium, the opposite sides of a trapezium. Yes, there, Isa's got it. It's 85. 85 because AB is parallel to DC. So 95 and D will be co-interior. So you have to go 180 minus 95. That gives you 85. And then the same with C. There's a long explanation there, but that's basically what it comes down to. Okay, I'm actually, yep, let's go out of that. And back to our actual notebook. Let's just share this again. Okay, so what I want you to do is take a screenshot of this here, this diagram here, because I want you to, before Tuesday, actually go and fill it out. It says with the help of a teacher, but I think you can do it on your own, because from what I've seen, you guys actually know your properties fairly well. But I want you to have this so that so that you can use it as we go through our quadrilaterals. I will share the answer with you on Tuesday, but I want you to first go and think about, oh, there, I'm showing the answer already. Well done. Well done. Anyway, if you were quick, then you maybe got some of the answers, but it's not a secret. It's just, you just have to fill in. Okay, right, everyone. So you know what I'm gonna do? I'm gonna do this. I saw Mr. Skitter do this. Makes things really, really small so that no one can see them. Okay, guys, so what's going on here? Tsiamu, let me tell you. It's basically just each shape, and then you list the properties below each shape that relates to it. And think of the sides. What are we going to say about the sides? The angles, the diagonals. Okay, don't worry so much about the symmetry, and don't worry about what it says here with the A. That actually stands for area, but we're not going to worry about area now. Area is something you did in grade 9. So we're just interested in what you can say about the sides, the angles, and the diagonals. Oh, the memo situation. Don't worry, Tsiamu, the memo situation has been dealt with. Okay, right. Does everyone understand what to do? Just put a thumbs up in the chat if you got it. If you got a screenshot and you know that you need to go and fill that out. Awesome. So what we're going to do for the rest of the lesson is just do some more quiz-like questions about the properties of quadrilaterals. So be fast in the chat. Oh, Inati, sorry, Inati's got her hand up, or his hand. Inati, we haven't met you yet, so let's hear. What can we do for you? Oh, Inati says it's a mistake. Okay. Right, so true or false? Actually, what I'm going to do is I don't want answers yet. I'm going to give you a chance to answer each question on your own. We're going to work for about 4 minutes, and then we'll check back with answers for this true or false. Okay, so don't put anything in the chat. Keep it a secret until we check back in and compare answers. Okay, so let's do 3 minutes. You're just writing true or false, and you really can just write T and F, T or F. So just keep your answers to yourself for now. No, Ntandukasi, you must keep it to yourself. Okay. Keep it on the down low. Okay, 1 more minute. Okay, right. So let's hear. All quadrilaterals are polygons, true or false? Pop it in the chat. Yes, Nokwanda. Nokwanda, do you have a question or do you want to answer? You're welcome to answer. Unmute and answer.
No, I don't have a question.
Okay, your hand's up. Okay.
True.
It's true. Thank you. Okay, I agree. That is true. All polygons are quadrilaterals. Is that true or false?
False.
Okay. That is false. Yes, all polygons are not quadrilaterals. They can be pentagons, hexagons, octagons, all of those. Okay, all parallelograms are quadrilaterals. True or false? Pop it in the chat. That is true. All parallelograms are quadrilaterals because of the 4 corners and the 4 sides and the 360-degree angles. All quadrilaterals are parallelograms. That is false. Nice. A rectangle can be classified as a kite. Question E. Can a rectangle be classified as a kite? No, that's false. Can a kite be classified, question F, as a parallelogram? False. No, because a parallelogram's got the opposite sides that are parallel. So it's got to have that. Otherwise, it's not a parallelogram. And a kite doesn't have that. A kite can be classified as a rectangle. True or false? False. I agree with that. Because of the 90-degree corners, a kite does not have 90-degree corners. All rhombuses are parallelograms. True or false? That indeed is true. It is true because the rhombuses have opposite sides parallel, which makes them parallelograms. Can we have the other way around? All parallelograms are rhombuses. True or false? That is false. Because all parallelograms do not have all sides equal, which is what makes a rhombus a rhombus. Okay, and then all rhombuses are quadrilaterals. That is true. Okay, well done. We've got one more little exercise to do. And what we've got here, this is going to make you think, I hope. We've got a table. We've got these shapes, and we have to say in the table whether they are quadrilateral, trapezium, kite, parallelogram, rectangle. So we're going to tick all the ones that apply. Okay, I'm going to do the first one with you to help you. So the first one, opposite sides are parallel. So first of all, that's a quadrilateral. It's got the 4 corners. Opposite sides are parallel. It can be a parallelogram. And yes, that's it, I would say. Okay. Now, you don't have to draw the table. You can, just for the remaining 3 questions, you can just maybe write down where you would have ticked, which ones you would have ticked. Okay. It can't be a trapezium vucilo for the first one because a trapezium has 1 pair of opposite sides equal. For rectangle, it needs the 90-degree corners, okay? So we can only say it's a rectangle when it's got the 90-degree corners. Okay, so do the remaining 3 questions as best you can, and then we'll check back in about a minute. Okay, are we ready? This is too difficult. I told you it was going to make you think. Opposite sides are equal for number 3. Think about that. Which quadrilaterals have opposite sides equal? Yeah, so tick the ones that it applied to. Square have all the sides equal. Okay, so maybe 4 is a square, but 4 could also be something else. Okay, right, let's look at the answers. I'm going to move this up. Okay, so number 2, that is a trapezium. Why is it a trapezium? Because 1 pair of opposite sides parallel. For question 3, it could be a parallelogram because the opposite sides are equal. Okay, so for 3, you should have ticked quadrilateral or parallelogram. Why is it not a rectangle? Because what's missing is the 90-degree corners. Okay, what makes a rectangle is the fact that it's got the 90-degree corners. Okay, and then for number 4, definitely quadrilateral, parallelogram, rhombus. Okay, because a parallelogram can have all its sides equal or the opposite sides equal, and then a rhombus has all its sides. And as we've now explored a few times in the PowerPoint and in the true and false, a rhombus is a parallelogram. Okay, Chinamiram, ask a question if you're confused. Ask questions, guys. Raise your hand. Yes.
Ma'am,
Yeah.
ma'am, for number 2, you said that it is not a rectangle because it doesn't have a right angle. But then,
For 2.
yeah, but then for number 4, all sides are equal and that makes it a square. But it doesn't have a 90-degree angle.
Yes, so that's why it's not a square. We didn't tick that one for number 4.
Oh.
You can only tick rectangle and square if there's a 90-degree angle. Otherwise,
okay.
the best you can say is that it's a parallelogram or a rhombus for number 4.
Okay, ma'am. Thank you.
Okay. All right, for Chilu, if you have a question, you must ask. But then why is it a parallelogram? Because a parallelogram have both pairs of opposite sides equal. So that's why. But that means as well that all the sides can be equal. Okay. It's a little bit confusing, but if all the sides are equal, then both pairs of opposite sides are equal. Okay. All right, Miss